So very good afternoon to all. Okay. Okay. So in the last class, in previous class, we have seen so different methods of blood flow rate. Blood flow rate. How we can measure the blood flow rate. So we are having 5 methods indicated. So the first one is electromagnetic induction, ultrasound transmission or reflection, thermal convection, radiographic principle, and indicator method. So based upon these methods, we can measure the blood flow rate in a blood vessel. For a given blood vessel, to measure the blood velocity or blood flow rate, we can use these 5 methods. So the last class we discussed about electromagnetic induction principle, and second one is ultrasound transmission or reflection methods, and the third one is thermal convection method. So now we'll see the thermal convection method. And today's lesson will continue the measurement of blood flow measurement. So in the blood flow measurement by thermal convection. So thermal convection means, suppose we have a hot body which is producing a continuous heat. Suppose we have a hot body which is producing continuously hot body, continuous producing the heat, which is producing heat continuously. Okay, suppose a cold air is pumped to this hot body. Suppose circulation of the cold air cold air to this hot surface body. So then what happens? So continuous supply of the cold air, so that particular hot body temperature will be decreases. So here the main point we have to consider is the hot or temperature of the body will be reduces by pumping the cold air. So this is a heat transfer. The hotness of the body will be transferred to the cold air. So this particular phenomenon we can consider as a thermal convection. Thus, this type of thermal convection principle is used to measure the gas flow. Generally used in gas flow in a pipelines. The same principle is also used in blood velocity, to find the blood velocity. So here in this case, we will use a thermistor in the blood vessel. So suppose we want to find the blood flow in a given blood vessel. So first of all, we will place a thermistor in the blood vessel. So by placing that thermistor in the blood vessel, it detects the temperature of the actual blood flowing temperature. Okay, suppose the blood velocity or blood flow is increases at that moment, at that particular place of the thermistor, the temperature was changes. suppose assume that initially the blood is moving at normal rate, okay. So due to that, the temperature measured by the thermistor is recorded, okay. And suppose if the blood flow rate is increased, if the blood flow rate is increased, then what happens? The temperature of the temperature at that particular point will be changes. That change in temperature will be recorded by the thermistor, okay. The amount of the variation in the thermistor value will indicates the blood flow in the blood vessels, okay. So change of the temperature is causes due to flowing of the blood in the blood vessel. The change of the temperature is causes in the blood vessel due to flow of the blood is increased or decreased. If the blood velocity is increased, the blood velocity is increased. So then, so the amount of the flow will be increases, and due to that, at measuring point, the temperature was changes. The change in temperature variation can be identified as a blood flow velocity. So this is one method we can use it for measurement of the blood flow. And another method, so in this case, so we will use a thermocouples or thermistors. We can use thermocouples or thermistors. Two thermocouples we will consider, we will take, and in between these two thermocouples are placed a distance between we will place two different places of the blood vessel. Okay, so here we will consider two thermocouples or thermistors, any type of the temperature sensors. So thermocouple or thermistors, these sensors will be placed in a blood vessel. So the presenting screen is same. So this is one method we are using thermal convection. The same convention principle is used by using two thermocouples. So which are placed in two different places of the vessel. In between we will place a heater. Okay, so heater. So by the when uh, when the blood is flowing through the heater, there is a temperature variations will be occur. So those temperature variations will be determined by the thermocouples. Okay, so here we will place a heater. Electric heater will be placed between two sensors. Okay, and due to temperature variations, so suppose if the blood is moving from one place to another place, suppose assume that downstream and upstream. So in a vessel, blood vessel, we have one sensor is downside and another sensor is upper side. In between we are placed a heater. So when the blood is moving or flowing from down to upward direction, so that blood will be senses the heat, and due to that, before heater we have one sensor, after the heater we have another sensor. So we will consider the difference of these two sensor outputs, and that difference of that voltage will represent the velocity of the blood flow. So you can see just here there is no figure to represent here. So that's why. So suppose assume that a pipeline is there. Suppose a pipeline is there. So in that pipeline, a gas is flowing. Okay. So for the pipeline, upper side we have a sensor and downside we have a sensor. Between these two sensors, at the outside of the pipeline, we place a heater. Now this heater is producing the heat. So in the down when the gas is flowing through this pipeline, before the heater, sensor will senses the before heating up of the gas, the sensor will senses the temperature. Assume that that is T1. And after gas flowing through the heater, the gas will consumes the heat of the heater. And after reaching the second sensor at the top side, it will senses the temperature. That sensor will be observes the measures the okay. Yeah. So actually for this explanation there is no figure is not there. Okay. So that's why I'm just saying like this. So that's why I'm saying assume that a pipeline is there. Okay. This pipeline is assume that it is a blood vessel like veins and arteries. Okay. So for this pipeline we are placing two temperature sensors for a distance, and in between these two sensors we are using a heater. When the blood is flowing through this pipeline or the gas is flowing through this pipeline, so what happens, it will senses the temperature and it will move through the two sensors. Before reaching the heater, before reaching the heater, the gas having certain temperature. After receiving the or absorbing some heat from the heater, it will has high temperature. So the difference of the two sensors, the upper side sensor will measures the heat. Okay. And those two difference, the difference of the two sensors will be measured. So if the blood flow rate or if the gas flow rate is increased, then the absorption rate is decreases. If the blood flow rate, if the gas flow rate is moving slowly, then it absorbs more heat, and due to that the higher due to that higher sensor has a high temperature, and difference of these two temperatures will reflect the flowing of the gas. So the similar principle is used in blood flow measurement, blood flow rate. Okay. So this type of method is known as a thermostraher. Assume that this is a pipeline. So through this we have a gas flow, or blood flow. You can say it is as a gas flow. Okay. So here this is the this one is a heater, and here we have a sensor, and here we have another sensor. If the gas is flowing through this pipeline at a certain velocity, okay, that gas will absorb the heat produced by this heater, and these two sensors will sense us before gas enters into the heating region, and this sensor will sense us after gas going outside of this region. And suppose assume that um, uh, this is the temperature of T2 and this is the temperature of T1. Okay, so generally by observing the heat, the gas flow temperature is at T2 is higher than T1. So difference of temperatures will be considered as T2 minus T1. T2 minus T1. Difference of these two temperatures. Suppose the gas flow rate is, velocity of the gas is increased, or more speed is there. Velocity is increased. Gas velocity is increased. Then, so the contact region of the heat will be decreases. The absorbing rate of the gas with the heat will be decreases, and due to that, difference of the temperature will be decreases. If the gas flow is moving with slower velocity or less velocity, then what happens? The gas will be absorbs the heat, and due to that, it will be having higher value of temperature, and due to that, the difference will be increases. So like that, similarly, the same principle is applied for the will be applied for the blood flow rate. Okay, so this is the blood vessel. So we can say it is blood vessel. It's like a veins or veins. Okay, so the blood is moving in this direction with certain velocity. Okay, and here we have a heater near to the arteries or veins, and due to that, the temperature in the blood of the blood is changes before the and after the heating. So due to that, there is a variation in the temperature. So that by measuring the temperature difference, we can identify the blood velocity or blood flow velocity. Okay, this is the basic idea. So, are you get my point? And next one, the next type of measurement method is by using radiographic methods. So radiographic methods. So this is whenever we will take a X-ray, so we will get only the bones. The bones are we will get the X-ray of the bones only. So why would we don't get the blood cells X-ray? We don't get any blood cells related indication. So only we will get the bones. So why it is happening? So because the radio density of the blood cells is same as the X-ray. So normally the X-ray image will gives only the white color. So the white colors that indicates the bones, and remaining are it will does not shows, because those blood cells are the radio density of blood cells is near to the X-rays. That's why it is not shows the image. Okay, but the contrast of the the contrast of the blood vessel will be increased by injecting a iodated organic compound. By injection process, we will inject a iodated organic compound into the blood vessel, and due to that, what happens? There is a contrast of the blood will be increases. So visibility of the blood will be increases. So whenever it is increases, so we can take the X-ray image. So we will get the blood movement, the blood flow. The blood flow continuous recording we can make by using photographic or videotape recording. By using photographic or videotape recording. So with this method we can record the how the blood flow is moving. This progress of contrast medium can be followed. Okay. So with this method we can find the if there is any obstructions in the vessels. We can also measure the blood flow and obstructions in the veins or arteries. And this method is known as cine or video angiography. So I think we may listen this word angiography. So suppose after doing heart surgery, after doing the heart attack or a heart stroke, so we can identify the damage of the heart with this method. Suppose there is a heart attack was happened, so up to what level the heart was I mean heart attack was happened, so that heart stroke was happened, so that we can be identified with this radiographic method. So in this we will pump or inject a organic compound into the blood, so that will be increases the contrast of the blood. So that can be easily identified or recorded by the X-ray imaging process method. So this is photographic or videotape recording. Two methods we can do X-ray imaging. Continuous process. It is a recording of continuous process. And with this we can identify the is there is any obstructions in the arteries or veins. So that can be identified easily. And also we can measure the blood flow. So this method is known as a angiography, cine angiography or video angiography. And another method is there. So that is in place of organic compound, iodated organic compound. So we can also use radioactive isotopes. So these radioactive isotopes are injected into the blood circulation, which allows detection of vascular obstructions. So generally the heart attack is obtained by there is some obstructions in the arteries and veins. So those in the blood vessels there is some obstructions will be occurs, and those obstructions should be identified or detected by using radioactive isotopes or injected into blood circulation. By injecting radioisotopes in the blood circulation, we can identify the is there any obstructions in the vascular in the heart muscles. Similarly, vascular obstructions in the lower extremities can be detected by measuring the differences in skin temperatures caused by the reduced circulation. Suppose due to obstructions in the um, obstructions in the vascular lines or blood circulation paths, vena cava inferior vena cava. So due to that, what happens? The blood circulation will be reduces. the blood flow will be decreases, and due to that what happens, due to changes in the blood flow, so there is a temperature variations will be occurred in the body. So where the variations in the variations in the blood circulation, that causes changes of the temperature of the skin temperature will be changes, and that differences will indicate the obstructions in the blood flow, obstructions in the arteries and blood circulation paths. So skin surface temperature measurement, with this is skin surface temperature measurement, we can identify the difference of the skin temperature, and from that we can uh, detect the obstructions. Okay, this is another method by using by measuring the skin temperatures, by measuring the difference in the skin temperature. Okay, skin temperature, how why do changes means, so due to changes of the blood circulation. And the next one is measurement by indication dilution method. Indication dilution method. So in this method we will so a material which is so this is a open circulation method. So this is open circulation method. So here we have an injection. So in this injection process, so we will inject a material. Okay, so that material will will melts with the blood. It will be resolves in the blood, and due to that, so here that blood circulation will be detected by the detector at the other end of the this blood flow circulation path. Okay, so this is only measures the blood flow, not it does not measures the velocity. So by mixing the material with the blood, so there is a concentration of the that injected material substance will be changes. The concentration of the substance will be changes. That change in substance will be measured with a detector. So here we have a, so how much flow is there, so that will be identified by, so the amount of injection rate, I is how much of amount you are injected, milligrams per minute. So with respect to time, certain amount of time we will inject. So okay, so how much of amount of substance we are injected, and it will be mixed with the blood, and due to that, and due to that the concentration of the blood will be changes, and that change in concentration will be identified by the detector, and that is C naught. C naught. C naught is milligrams per liter for a given amount of the blood, given amount of blood. Suppose it is in a liters, we can measure the how much amount of substance was concentrated. So that depends upon the blood flow, how much flow rate is there. Suppose the blood flow is very high, so then what happens, the injected substance will be more, it will be consumed more, it will be concentrated. So and the amount of the material or substance receives more amount will be received, and due to that this detector will be identified more amount of the substance, and that gives the blood flow. Okay, so like this we can measure using dilution method, indicator dilution method. So after continuous injection, so the concentration becomes as a constant. Here we have at the time of I we are injected for measurement of indication dilution measures substance to the injected time t is equals to at this point. Okay, at this moment the continuously we are injecting the material or substance, some substance which is mixes with the blood, and that substance does not affect the does not create side effects, does not create the side effects. So for that we can use a radiated serum albumin, a material you can call it as a radiated serum albumin. So in some cases we can use a saline. In the saline also we can in saline we can inject. Okay, so by through that by the saline we can inject, and that will be mixes with the blood, and that other side of the blood circulation path we can detect that material. The blood flow is very high, the blood flow is very high, so it does not, the material which is injected does not mix with the blood, and due to that the output the detect output is becomes as low. The output detector output is low, so when it is low, so it is having flow high flow rate. If the flow rate of the blood is very low, it will the injected material will mixes with the blood, and due to that the concentration will be becomes more, the concentration is more, and at the other side of the circulation path we will detect that concentration, so this concentration will be high. When the concentration is very high, the blood flow is very low. So with this equation we can identify the blood flow rate. So this is milligrams per minute of you can inject the substance, how much amount of milligrams we are injecting with a given time, with a given period of time. So this is the continuous injection, so the concentration is making it as a constant. So continuous injection, after certain amount of time the concentration becomes as constant. After reaching here, the detector will be identify the concentration. If the blood flow is more, that material does not concentrate into the blood. Okay, and due to that the detector output is very low, and that value is low means it is having high blood flow, so flow rate is very high. Similarly, it is blood flow is moving very slowly, blood flow is very moving with a very slow, so then the injected material will be easily mixes with the blood, and due to that the detector will be identified more amount of the substance, that is C naught will be very high value, and due to that it is having low low blood flow rate. Okay, so like this we can identify the blood flow of the blood flow using dilution method. So up to now, you have any, you want any clarifications or again explanation, you can ask. Okay. So with this, I'm closing this session.